Okay, so now we are going to go through section 4, the calculator portion. Now I will break this up into multiple parts, so just make sure you guys pick the right video if you're trying to find the questions that correspond to your questions. So starting with number 1. The graph above shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is the closest time she finished lunch and continued her hike? So based on this graph, you can see she was hiking. She was climbing. And then all of a sudden, she just stopped climbing, okay? Or she stopped hiking because their distance from the campsite is not changing for this period of time, okay? So as a result, you can see during that time she stopped and then she just kept going on. So right there must have been where she took her lunch. So the question is, based on the graph, which of the following is the closest to the time she finished lunch and continued her hike? That would be right around here. So that's towards the later end between 1 o'clock and 2 o'clock. So if I had to pick, it's not 12, it's not 1:10 because that's pretty early. It's not 2 o'clock because she was actually doing something right there. It is probably going to be 1:40. So we're going to go with that answer. Number 2, the table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under age 40 or a male age 40 or older? So since it's the probability, what I want to know is, okay, how many people are there total that this could be out of? And the answer is 25. So how many people am I actually caring about? Well, it said the female under age of 40, so that would be female under age of 40, or a male 40 or older, male 40 or older. So that is 10 out of 25. Now, that answer is right there. So there is that. Number 3. The graph below shows the total number of music sales albums in millions each year from 1997 through 2009. Based on the graph, which of the following best describes the general trend in music album sales in 1997 through 2009? So sales generally increased each year since 1997. It doesn't seem that way because they increased for this time, but then they started to decrease. Sales generally decreased since they increased a little bit. Generally speaking, maybe they did, but there was a good amount of time they increased. Sales increased until 2000. So let's see, if this is 1997, then this would be 1998, 1999, 2000. So right about there. So yeah, they were going up until 2000, and then they started going down. So that actually makes a lot of sense. Generally, sales generally remained the same or steady from 1997 to 2009. No, they were moving around. So the best one that makes sense is C. All right. The table above shows values of a linear function f, which of the following defines f? So if it's a line, you know there's a slope. How do I find slope? Remember, it's y2 minus y1 over x2 minus x1. So what am I going to do? I'm going to do 4 minus 1 over 3 minus 2. I just picked any 2 points. I picked the middle 2 points because I just picked those since I didn't see a negative. And that gives me 3 over 1. So I know we have a slope of 3. Which of these answers has a slope of 3? There's only one of them. So the answer has to be C. Okay. Number 5, at Lincoln High School, approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted to the National Honor Society. If there are 562 juniors and 602 seniors enrolled at Lincoln High School last year, which of the following is the closest total number of juniors and seniors at Lincoln High School last year who were inducted to the National Honor Society? So for this one, what we're trying to see is there's 7% of all juniors, and there were 562 juniors. So 7%, remember, we have to do 0.07 times 562. And then the same thing is going to be 0.05. Don't forget to move that decimal place 2 places of 602. And then luckily, this is the calculator allowed portion where I can do this kind of stuff. And I figure out that 0.07 times 562 is equal to 39.34 students. And 0.05 times 602, right on my calculator, gives me 30.1. So in total, that gives me somewhere around 69 students. So luckily, that is the answer right there. Okay, which of the following is the sum of the two polynomials shown above? Okay, so the question is, do you remember your rules of exponents? If I add these two together, 3x squared plus 5x squared, that's definitely going to give me 8. Do I change the exponent? The answer is no. You do not want to change the exponent. You are combining like terms, the exponent stays the same. So automatically rule out C and D. Now I have no reason to check the last one because you can see the last one's going to be -4. What about the middle one? What's -5x plus -2x? Now, what am I adding it? Because it says the sum, and that gives me -7x. So that gives me A. Okay. Moving on to number 7. If 3/5, I'm going to rewrite this, W, is equal to 4/3, then what is the value of W? A couple ways to do this. If you want to use your calculator, that's fine. 3/5 is attached to W by multiplication, so I'm going to divide by 3/5. However, when you divide in the calculator fractions with fractions, it gets very, very messy. You have to put parentheses. So you have to parentheses 4 divided by 3, close, divided by parentheses 3/5. The calculator doesn't know where the division is going to start and stop, so I have to do this. Okay, and therefore, if I do that, I should end up getting 20/9. Now, your calculator is going to give you a decimal. What you can do is you can hit math, enter, enter, and it'll convert it back into a fraction for you. The other thing you could have done right from the beginning is if you take 3/5 of W, you can also multiply it by the reciprocal, which means the flipped version. And if you did that, these cancel. I'm left with W equals 4 times 5 is 20, 3 times 3 is 9. That's another way of doing that. Number 8, the average number of students per classroom at Central High School from 2000 to 2010 can be modeled by this equation. This equation is linear, where X represents the number of years since 2000 and Y represents the average number of students per classroom. Which of the following best describes the meaning of the number 0.56 in the equation? Now, 0.56 is the slope, right? 0.56 is the slope, which means the rise over run. So I'm looking for something that talks about keywords like rate. Rate means slope. And since X is the year, what I'm basically doing is multiplying 0.56 by the year, and that'll tell me how much it goes up by, right? So if I read through them, A, the total number of students in the high school is 2,000. That doesn't even talk about 0.56. I don't understand that one. The average number in the students is 2,000. Again, that really does not make any sense because it's just the year 2000. The estimated increase, so now we're talking about rate, okay, in the average number of students per classroom each year, that would be 0.56, but let's see what D says. The estimated difference, not subtraction, it's the estimated increase between the average number of students per classroom in 2010. So not this one, it definitely is this one, because of the concept of slope. Slope is a rate. How fast is something increasing or decreasing? Not a difference, and definitely not anything from A or B. Okay. Number 9, Nate walks 25 meters in 13.7 seconds. If he walks the same rate, which of the following is the closest distance he will walk in 4 minutes? Okay, so a little bit of unit conversion here. First of all, what is 4 minutes in seconds? 4 minutes converted into seconds. Okay, I'm gonna have to ask myself how many minutes are in a second. There are 1 minute every 60 seconds. So I'm gonna convert that. So not 4 minutes, but 240 seconds is gonna be way easier. Okay, So if Nate can walk 25 meters in a 13.7 seconds, so I'm gonna write this 25 meters in 13.7 seconds, that's equal to how many meters, I'm gonna call that X, in 240 seconds, okay? And what I can do, cross multiply this times this equals this times this. So 25 times 240 is 6,000 equals 13.7x. Divide by 13.7, divide by 13.7, you get about 437.95. So if I had to estimate which one's closest, definitely B. Okay. All right. Questions number 10 and 11 go from the table. So go ahead and read the table, but I'm going to go ahead and jump right into this part right here, which says, the chart above shows approximations of accelerations due to gravity for the 8 planets, and this is the equation I'm going to have to use. Weight equals mass times gravity. Okay. So number 10, what is the weight in newtons, so I'm looking for W, of an object on Mercury? Okay, so we're talking specifically about Mercury, 3.6, with a mass, so the mass is 90 times 3.6, and 90 times 3.6 is 324. So that answer has to be D. No big deal there. Now, for 11, that one's a little trickier because it kind of requires some back and forth. An object on Earth has a weight of 150 newtons. So on Earth, which is a gravity 9.8, has a weight of 150 newtons. So let's see, weight equals mass times gravity. So if I have a weight of 150, I don't know the mass, but the gravity is 9.8. I can quickly find out that the mass is whatever 150 divided by 9.8 is, which is about 15.306. On which planet would the same object have an approximate weight of 107 newtons? So again, if I use this equation, I actually don't know G because I don't know what planet I'm on, but I know what mass is, and I know what the weight is, 170. So 170 equals 15.306 times G, right? So I'm going to divide by the 15.306. So 170 divided by 15.306, and that gives me about 11.1. So which planet has a gravity value of 11.1? It's got to be Saturn here. Okay. All right, number 12. If the function f has 5 distinct zeros, so that means it crosses the x-axis 5 times. That's what a zero means, crosses through the x-axis. Which of the following could represent the complete graph of f in the xy plane? Well, if I count up the times it crosses through the x-axis, 1, 2, 3, 4, not enough. 1, 2, 3, 4, not enough. 1, 2, 3, 4, 5, 6, too many. 1, 2, 3, 4, 5. Got to be this one. You have to know the idea of what a zero is, and a zero is simply when the graph crosses through the x-axis. Okay, number 14. The cost of, oops, sorry, we skipped number 13, didn't we? 13 is down here. Number 13, the equation above gives the height h in feet of a ball t seconds after it's been thrown straight up in the air. Which of the following gives v in terms of h, t, and k? So a calculator is not really going to help you here, but you have to try to solve for v. Okay, so let's talk about how you would solve for v. Let's rewrite this equation. X equals negative 16t squared plus vt plus k. In order to solve for v, what I would do is I would just move these things over. How do I move them? Add 16t squared, subtract k. So I have h plus 16t squared minus k equals vt. And then to get v by itself, I have to divide by t and divide everything by t. Now you see there's no answer that looks like exactly like this. Why is that? Because they chose to reduce everything by t. What does that mean? H over t plus 16t squared over t minus k over t equals v, because the t's cancel here. and you can actually reduce one of the t's. So you're looking for a 16 that's kind of down one t. So I have h over t plus 16t minus k over t. So this has a 16t, this has a 16t, this has a 16t. It's not this one. The 16t is positive, so I know it can't be this one, and it can't be this one. Oh, okay, it's got to be that one. And let's double check. H over t minus k over t is the same thing as h minus k over t plus 16t squared. All right, now let's take a look at number 14. The cost of using a telephone in a hotel meeting in a room is 20 cents per minute. So $20 or 0.20 cents per minute. Which of the following equations represents the total C in dollars for hours spent on the phone? So here's the thing. If I want to get rid of the dollars, I have to multiply that by minutes. But currently, H is represented in hours. So if I have H hours, how do I convert hours to minutes? Well, if you get stuck, just come up with numbers that make sense to you. How much is 1 hour? That's 60 minutes. How much is 2 hours? Well, that would be double that, so 120 minutes. So if I have in hours, I need to multiply 60 times the number of hours to get minutes. And then I'm looking for 0.20 times 60 times h. 0.20 times 60 times h is the answer to A.